Hello, my name is Aretha. I haven't uploaded a video with English audio for a while. I'm sorry. I had uploaded a video about some troubles with Intel, but I thought that with my insufficient English knowledge it might be misunderstood, so I only made the video in Japanese. I will start making videos in English again in the future. This is my second video about the Ryzen 7 8700G memory, but as the title says, it didn't go as planned in the last video. It would take a long time to explain, so I'll explain the reasons when I have some free time. The purpose of the video is the same, to talk about how much performance can change by tuning memory when using the 8700G. Last time I talked about the variation in performance per frequency. What happens if the memory timings are set properly? Even though I said it was set properly, I think there are some parts that aren't set properly. Please forgive me in this regard. There are some parts that I myself find strange. As I mentioned in a previous video, I'm not good at memory-related settings. I'm sure there will be some points that serious players will find questionable, but please bear with me. And of course, what I'm doing this time is overclocking. Please note that if you try to imitate this, you will be responsible for any damage that occurs. The testing equipment is mostly the same as before, but the motherboard and CPU have changed. The motherboard has changed from the Asus TUF Gaming B650M Plus to an ASRock B650M HDV M.2. Why did it change? You can guess. As for the CPU, it is still a Ryzen 7 8700G, but it is a different unit. There is not much difference in durability, so I think it is just a normal unit with no special features. The CPU cooler has also changed. It has gone from Shenzhen Fluence Technologies PC Cooler K4BK to Shenzhen Fluence Technologies CPSRZ400V2. In Japan, DeepCool is disappearing from the market for various reasons, but Shenzhen Fluence Technologies CPU coolers are recommended. The price and performance are excellent. Other than that, it is the same as before. Regarding BIOS settings when verifying memory that is not properly configured, load optimized default. Specify 8G memory allocation for iGPU. Memory timings are set to 36464686 for the primary, and the rest are set to auto. Memory voltage is adjusted as appropriate. The voltage around the CPU is also adjusted depending on the situation. As for the BIOS settings that are set when validating properly configured memory, load optimized default. iGPU memory allocation specified as 8G. Memory timing was adjusted to give the best possible performance for each frequency. This time, I tried running 6400 and 7600 with the timing adjusted. The Infinity Fabric is also set to 2400. The various voltages are adjusted so that no errors occur, but I don't think it would be useful to set it to an unrealistic one-shot record, so I set the VDD voltage at an upper limit of 1.52 volts. If the voltage is around this level, I don't think there will be any problems with operation as long as the wind is properly applied. Of course, if you copy it, you do so at your own risk. And since it is set up assuming regular use, it also passes the memory error test. However, is test mem5's 1 USMUS pronounced as 1 azimuths? I've only run the V3 setting for an hour, so it's not at a level where I can say it's completely stable. If you're aiming for regular use, I think it's better to run Absolute and PCB Destroyer as well. If you use this as a reference, please do your own error tests. The benchmarks we will be verifying are Final Fantasy XIV Dawn Trail Benchmark VR 1.1, Final Fantasy XV Benchmark, Blue Protocol Benchmark. Final Fantasy XIV Dawn Trail Benchmark VR 1.1 is standard desktop Full HD. Final Fantasy XV Benchmark is low quality Full HD. The Blue Protocol Benchmark will also be run in low quality Full HD. I ran the Timespy Firestrike Nightraid Steelnomadlite that can be run on the demo version of 3DMark. The frequencies we will be testing will start from 5200 and go up to 8000 in increments of 400. At 8000, an error occurs in TM5, so please use this as a reference only. In the second half, we will also check the data when the appropriate timing is set, so that everyone can see the power of memory timing. Now, let's talk while looking at the scores. First up is the Final Fantasy XIV Dawn Trail Benchmark Veer 1.1. This was done with the new version. It's heavier than the previous Final Fantasy XIV benchmark, and it seems that this bench puts a lot of strain on the Infinity Fabric. So it looks like it could be used for that purpose in the future. It's heavier than the previous version, so it will likely be difficult to get a comfortable score with the 8700G. The score improves steadily with the frequency, but for the 8000, the score has dropped, perhaps due to errors. In the previous environment, the 8000 was full of errors and the test would not pass, but in the current environment it passed. I think this is a benefit of the B650 MHDV M.2. which is inexpensive but has a very excellent design. Next is the Final Fantasy XV benchmark. Unlike last time, I was able to get it to pass 8000. That said, it seems like it would start to throw an error if I ran it dozens of times. I've been playing around with the 8700G a lot lately, so I no longer feel uncomfortable with the low quality of the graphics. It's scary to get used to it. I think it's amazing that an iGPU can run things this well, and it really opens up new possibilities. I'd like to try out Monster Hunter Wilds with iGPU. Next is the BlueprotocolBenchmark score. Unfortunately, BlueProtocol's service has been announced to be discontinued. I've never played it, though. With toon shader style games like these, even at low quality the appearance doesn't deteriorate as much, so it might be a good match for the iGPU. I wasn't able to get this benchmark to pass 8000 before, but I was able to pass it this time. I really wanted to get it to pass 8000 when testing, which is why I decided to replace the motherboard. I might make a video on the B650 MHDV M.2 at some point. I had heard it was excellent, but it exceeded my expectations in a good way. Now, we'll move on to the 3DMark test. First up is everyone's favorite Timespy. It's been a long time since I last ran 3DMark, and the interface has been made more convenient in many ways. It automatically recognizes your environment, and it's easy to visually see how you compare to the registered score. If you get the paid version, there are more tests, and although it's not related to 3D graphics, I think the storage benchmark is excellent. Crystal Disk Mark is excellent, but it has become so popular that there is a theory that countermeasures are being taken. This benchmark mainly measures response, and you can get very useful information. I guess the only downside is that it's expensive. Next up is Firestrike. Because the score is close to 10,000, it's become a global trend to try to reach that score. That's a lie, it's only popular in certain circles. It's not an easy score to reach, but it's possible to reach it without pushing yourself too hard, so I think it would be a good learning experience to try it as practice. I'll try it next time, too. Next up is Nightraid. The machine that comes out looks like Moonlight from Metal Gear. Since it's a laptop benchmark, the load is light. I wonder what scores the newer laptop benchmarks like Ryzen AI and Lunar Lake get. I'm interested. I'm sure you can find the results somewhere if you look. Next is Steelnomadlite. There are tests that can be run on the demo version that are not light, but I am using light because I am testing it on an iGPU. By the way, when I ran the non-light version, I got a terrible score. I felt that even the light version was clean enough. I think you are used to iGPU. Now I've run all the benchmarks. The results are as I mentioned in the previous video. From 5200 to 7600, performance improves depending on the frequency, but at 8000 the score drops. I think this is due to an error. Since the environment has changed, I measured everything again. Well, the long undercard is over. The actual performance starts from here. We run the benchmark with the timings set appropriately at 6400 and 7600. There is a common belief that memory timings don't make much difference no matter how you set them, but this thinking is incorrect. In some environments and with some software, you may be able to gain an advantage by tightening the memory timings. If you use those environments or software. Also, if you want to squeeze out more FPS from your games. If you want to reduce latency in your environment. For people like that, I think it's definitely worth trying memory tuning. Of course, there won't be a dramatic change in all environments, so I don't think it's something you should do at all costs. Please use the data as reference. Now, I'll introduce the timing settings I'm using. I'll post a screenshot of Zen timing, so please pause to take a look. Serious players will probably find some issues with these settings, like how the FAO is weird, and how the SCL is all loose. If it's any tighter, an error will occur, so it's set like this. I mentioned the voltage at the beginning. VDD is 1.52 volts. VDDQ is 1.49 volts. Here is the Final Fantasy XIV Dawn Trail benchmark version 1.1. Tight 6400 is better than loose 7600. The performance has increased because it is an iGPU. With a normal PCIe graphics card, the improvement is negligible, but the Ryzen 7 8700G, which is an APU, is greatly affected by memory. Therefore, this much performance increase can be obtained. This is an extremely impressive result. In the case of the Tight 7600, performance is even better. To be honest, I knew from experience that performance would increase to a certain extent, but it's really easy to understand when you actually visualize it like this. Next is the Final Fantasy XV benchmark. Here we see the same trend. A tight 6400 is better than a loose 7600. A tight 7600 is even better than that. It's worth doing if it can improve performance this much. Setting memory timings is time-consuming and difficult, but when it comes to APIS I think it's well worth it. Next are the BlueprotocolBenchmark scores. The trend is the same as before. I think next time will probably be the last time I use it as a benchmark. The trend is the same, so there's not much to say. By the way, it took me about a week for each to create the settings this time. The 6400 was more difficult. This memory cannot reduce latency much. If it goes below a certain level, it will behave in a way that I don't understand. The 7600 was relatively honest. Now onto 3DMark. First up is Timespy. The trend is the same as before. The memory we are using this time seems to generate less heat. I am using P12 Max to blow the air. It doesn't heat up much. However, if you're using more than 1.5 volts, I recommend using individual fans to blow air on it. If you're using 4 memory, I think you should be blowing air on it even at around 1.4 volts. This is especially true if you're actually putting them inside a case and using them normally. Use a Corsair or Team Memory cooling fan, or find some other way to blow air on it. Next up is Firestrike. As I mentioned in the first half, there are people doing the 10,000 challenge. I will also participate. It looks like it's going to reach 10,000, but it hasn't arrived yet. But this data is the score with PBO off, so I feel like I could reach 10,000 if I just turned PBO on, but I haven't done it. I'll probably actually do it next time. Well, doing it normally isn't very interesting, so I'll try to make it a bit more interesting. Next is Nightraid. Regarding memory settings, I've published the timings I set this time. but I think results will vary greatly depending on the environment and person. I think results will also vary depending on the order in which you reduce them, and if you reduce TRP to the limit, it may be that the sub-timings no longer reduce. I think the skill is in figuring out which timings to reduce and by how much. However, it's not just about not getting any errors, but the difficult part of memory tuning is finding the most efficient part. I'm really bad at it, so I haven't been able to do it. Finally, there is Steelnomadlite. This is the last benchmark. I think that in all of the benchmarks today, in an APU environment, memory tuning has a big impact on game performance. If you plug in a PCIe graphics card, it doesn't have such a big impact, but if you ask people who do it properly, they'll tell you that it reduces FPS drops, or gives you an overall FPS advantage of a few percent. So although the impact is small, it's not a waste of time to do it. For those who are competitive gamers or those who just want to squeeze out the FPS, I think it's worth trying. Now, that's all the data. What we learned from this verification. I once again realized that memory speed is very important in an environment using APU. In an environment using a normal CPU, the difference isn't as big, but with an APU it has a huge impact. Above all, the Ryzen 8000 series has excellent frequency tolerance in its memory controller, so it's fun to tinker with it. With the X870 series motherboard that will be released in the future, ASUS Mother is. Support for the 9000 series is up to 8200, but support for the 8000 series is extended to 8600. As for the memory controller, it's better than Zen 5, so I think you'll be able to enjoy it even if you buy it now. If you just want to enjoy tinkering with memory, the 8500G should be fine. Rumor has it that many 8500s have better memory controller durability than 8700s. I'm looking forward to the next Zen 5 APU. Well, that's it for today's video. It would be boring if this was all there was to it. I haven't even released any data yet regarding the latency that I talked about in my previous testing. To be honest, I personally think that 7600 is boring. So, next time I'll try a higher frequency in this environment. The goal is DDR5 9000. I would like to verify it. We talked a little about it at X. We have confirmed that it is possible to boot the OS and complete some benchmarks up to DDR5 9800 in this environment. Of course, it's not stable, I've just confirmed that it works. So I'd like to aim for stable operation at DDR5 9000. Although it is not currently stable, I have confirmed that it can complete various benchmarks. I'm struggling to see if there is anything I can do. If there is nothing I can do, I will have to tolerate a few errors. It may end up being DDR5 8800. If it's 8800, please make fun of me. If it's stable even at 8800, that would be a level I've never seen in a video. Now that I've said this, I can't run away from it anymore. I'm serious about stabilizing it with DDR5 9000. Thank you for watching until the end.